Hello friends, the topic for today is interrupt driven IO. Now with interrupt driven IO, the CPU does not access the device until it needs servicing, and so it does not get caught up in the busy waits. In interrupt driven IO, the device requests service through a special interrupt request line that goes directly to the CPU, and then the request is processed. In today's video, you will learn the processing of interrupts. Let us start. Welcome to our channel Engineering and Technology for You. If you are not subscribed to the channel, kindly subscribe and press the bell icon so that you get notifications for future videos. The topic for today is interrupt driven IO. Let us start with the introduction. So here we are going to consider the role of processor in interrupt driven IO in more details. So the occurrence of an interrupt triggers a number of events both in the processor hardware and in software. Now these events, we'll see the events in figure 1. Now when a IO device completes an IO operation, the following sequence of hardware events occurs. First, the device issues an interrupt signal to the processor. Then the processor finishes execution of current instruction before responding to the interrupt. Now this part we have seen in the last video where we have seen the instruction cycle with interrupt. So in that we have seen that the processor will finish the execution of current instruction before responding to the interrupt. Then the processor tests an interrupt, determines that there is a 1 and sends an acknowledgement to the signal to the device that issued the interrupt. So the acknowledgement allows the device to remove its interrupt signal. So whenever a processor gets an interrupt, it will check for the interrupt and then immediately it will send the acknowledgement signal to the device which has issued the interrupt. So that the device can remove its interrupt signal. Then let us see the diagram. So here this is a simple interrupt processing. The changes in the hardware and software will be shown here. So the device controller or other system hardware issues an interrupt. So that is the first thing. So when it issues the interrupt, the processor will finish execution of the current instruction. So this we have already seen in the computer function in the last video. So the processor will finish the execution of current instruction and then processor signals the acknowledgement of the interrupt to the device, and then it will process the processor will push the program status word and PC onto the control stack. So this is nothing but the context is pushed onto the stack, and then the processor loads the new PC value based on the interrupt. So that is nothing but the address of the interrupt vector or address of the interrupt service routine. So that will be loaded into the say program counter so that the execution of the ISR can be there. And from here in the software part, save the remainder process state information, then process the interrupt. So process the interrupt means it will give the service required by the interrupt. Then restore the process state information and restore the old PSW and PC. So this is nothing but returning from the interrupt. So in this way the interrupt processing will be done. Now let us go to the next step, that is the processor now needs to prepare to transfer control to the interrupt routine. To begin, it needs to save information needed to resume the current program at the point of interrupt. So here we need some information, the status of the processor, which is contained in the register called as the program status word, PSW, or the flag register, and the location of the next instruction to be executed, which is contained in the program counter. So the contents of program counter and the program status words, they are they can be pushed onto the system control stack. So this is the minimum information required when it wants to return. So that will be pushed on the stack so that it will be easy for returning. Then the processor now loads the program counter with entry location of the interrupt handling program that will respond to this interrupt. If there is more than one interrupt handling routine, the processor must determine which one to invoke. So generally here, depending on the architecture and operating system design, there may be a single program, one program for each type of interrupt, or one program for each device and each type of interrupt. So this information will be necessary for handling the interrupts. So if there is more than one interrupt handling routine, the processor must determine which one to evoke. So that's why depending on that, it will invoke the particular routine. So it will contain the vector address for the ISR. Then once the program has been loaded, the processor proceeds to the next instruction cycle, which begins with an instruction page. So now the instruction page will be taking place by the contents of the program code. So the result is the control is transferred to the interrupt handler program. So the execution of this program results in the following operations. So it will contain the program for servicing the interrupt. So at this point, the program counter and the PSW relating to the interrupt program have been saved on the system stack. However, there is other information that is considered part of the state of the executing program. In particular, the contents of the processor registers need to be saved because these registers may be used by the interrupt handler. So these values plus any other state information need to be saved. Typically, the interrupt handler will begin by saving the contents of all registers on the stack. Figure 2 shows the simple example. So apart from the PSW and PC, the registers, processor registers, they are saved onto the by the interrupt handler program. So this is shown here in figure 2. You can see here. Now this is the main memory and this is the processor. Now processor has got the stack pointer. So every time it will make use of the stack for loading the programs. So this is the control, we call it as the control stack. So program counter, here it will be always incremented by 1, and these are the general registers. So first we are storing the program counter on the stack, and then the general registers they are put on the control stack, and then this is the interrupt service routine. Now this is the stack, then this is the interrupt service routine. So it will have the start and then return at the end, and this is your users program. So all are in the main memory. So the after say location n, the interrupt occurs. So here n plus 1, at n plus 1 this will take place. All this, the program counter will be saved here using the stack, control stack, and then general registers, they are also saved here. And then the interrupt service routine will start. Now in this case, the user program is interrupted after the instruction at location n. The contents of all the registers plus the address of the next instruction, that is n plus 1, they are pushed on the stack. And the stack pointer is updated to point to the new top of the stack, and the program counter is updated to point to the beginning of the interrupt service routine. That is what we have seen in the figure. It will point to the beginning of the interrupt service routine, ISR. Then the interrupt handler next processes the interrupt. This includes the examination of status information relating to IO operations or other events that cause an interrupt. It may also involve sending additional commands or acknowledgements to the IO device. So that is nothing but the processing of the interrupt. Then when the interrupt processing is complete, the saved registers values are retrieved from the stack and stored into the register. So this is again shown in figure 3. Let us see that. So here again, whatever is on the stack, it will be brought back here. So n plus 1, the instruction, so here the counter will have this value of that, and the general registers which were stored here, they will be back into the general registers, and the stack pointer will be again say pointing to the, always it will point to the top of the stack. Then here this, the same thing, the interrupt service routine, it is having the length y plus l. So up to this it will have, it is the interrupt service routine, it will be doing the interrupt processing. This is the user's program. So once everything this it in the return, everything will be done, and it will come back to this user program. So the final act is to restore the PSW and program counter values from the stack, and as the result, next instruction to be executed will be from previously interrupted program. So this is how the processing will be done. Know that it is important to save all the state information about the interrupted program for the later resumption. So this is because the interrupt is not a routine called from program, rather than interrupt can occur at any time and therefore at any point in the execution of user program. So its occurrence is unpredictable. That's why the information has to be saved properly. So this is how the interrupt processing will be done. So with this we come to the end of this video. If you have any questions, you can find me at Facebook, Twitter, Gmail or Instagram. Then if you like the video, press the like button, share with your friends and subscribe to our channel Engineering and Technology for You. And don't forget to press the bell icon if you want to get the notifications for future videos. Then thanks for watching. Have a nice day.